During the 2025 hydrological year, glaciers around the world lost an estimated 408 billion tons of solid ice. To put that staggering volume into a more visceral scale, that is the equivalent of 5 Olympic swimming pools emptying into the ocean every single second. While global melting has been heavily documented for decades, scientists have long looked to one specific region as a resilient, high-altitude failsafe. This is the Pamir-Karakoram mountain system in Central Asia. For years, these glaciers historically defied global warming, remaining remarkably stable while ice reserves elsewhere across the planet were in full retreat. However, data published in Communications, Earth, and Environment reveals that this stability has ended. Following an expedition to a monitoring station 3,400 meters up the Kizilsu Glacier, researchers found that these once resilient reserves crossed a point of no return in 2018. Since then, snowfall has declined sharply, while melting has accelerated. The breach of the Pamir anomaly is more than just a localized regional loss. It marks the failure of a major global stabilizer, indicating that even the planet's absolute most resilient ice reserves are now entering a violent state of collapse. Global glacier mass loss has accelerated significantly, rising from an average of 100 billion tons a year in the 1990s to nearly 390 billion tons today. To understand the physics behind this jump, the University of Kashmir tracked benchmark glaciers across the Himalayas for 3 decades. Their findings highlight a phenomenon called elevation-dependent warming. Temperatures at altitudes above 3,000 meters are rising more aggressively than in the cities below. This has pushed the equilibrium line altitude, the boundary where snow survives the summer, upward by as much as 300 meters. As this line climbs, lower mountain zones are losing the ability to sustain permanent ice. Geography is no longer a defense. Even extreme altitude cannot protect these reserves from rising atmospheric temperatures. The primary trigger for the Pamir collapse was a sharp, regional decline in snowfall. As the snow cover recedes, it exposes the jagged, dark mountain rock that was once buried under ice. This change in color creates a thermodynamic shift. While white snow reflects solar radiation, this dark rock absorbs it. The rock then radiates that heat, creating a localized effect that actively melts the surrounding ice. This creates a feedback loop. More melting exposes more dark rock, which generates more heat, further accelerating the loss of ice. The mountains have been transformed into active heating elements, using absorbed solar energy to destroy the very ice they once protected. Since 1975, the world's glaciers have lost a total of nearly 9,600 billion tons of ice. These mountain reserves serve as critical water towers for basins like the Jhelum and Amu Darya, sustaining downstream agriculture and hydropower. As these glaciers collapse, river levels will initially swell, creating a temporary surplus of water for the populations that rely on them. However, this increased discharge is a sign that the reserves are bleeding out. Once the glaciers diminish, the river flows will plummet. This current surge is an illusion of abundance. It is a precursor to a long-term decline in water availability that threatens the livelihoods of millions. Beyond the mountains, the 2025 melt alone contributed approximately 1.1 millimeters to global sea levels. That number represents the loss from mountain glaciers alone, excluding the massive ice sheets in Greenland and Antarctica. To counter this, glaciologists are now investigating extreme geoengineering solutions to stall the retreat. Proposals include constructing 100-meter-long dams in Greenland to contain erosion, or manufacturing artificial hexagonal icebergs to reinforce existing masses. These proposals highlight the scale of the crisis. The natural regulatory systems that once maintained glacier health are increasingly unable to counter the pace of atmospheric warming. Despite these technical proposals, the scientific consensus remains that the only definitive way to slow this process is a total reduction in carbon dioxide emissions. The collapse of these resilient glaciers suggests that the era of relative stability for Earth's ice reserves has passed. The transition to a more volatile state is already underway.